Hello everyone, welcome back to this channel. We are studying class 9 science in that chapter 9 which is a physics chapter whose name is force and laws of motion. In the previous video we talked about Galileo's experiment and law of inertia and how it is related with first law of motion. And we also studied and saw various videos in which activities were there and the real life examples were there. Same way, now after Newton's first law of motion, it is now time for Newton's second law of motion, right? So, before we understand Newton's second law of motion, let us understand one important physical quantity which is called as momentum. Now, for understanding what is momentum actually, let us understand this example. Right? It is a very simple example. Two examples are there in which you have just to imagine the effect of the force which is going on. Now, say when you pick a light stone, when you pick a very light stone and throw it on the glass plate with some velocity, it won't break the glass. So, let us conclude that it won't have any effect. But if in place of light stone you put heavy stone, what will happen? The heavy stone, if thrown at some velocity on the glass plate will break. So what is the conclusion? That effect of force, whether it is not breaking or breaking, that is the effect of force. It depends on the mass of the object, right? So force is dependent on mass. Now let us take example number 2. You all have seen a karate player uh, hitting the bricks and these tiles and everything with their hands and breaking them. But let us take an example in which a karate player hits his hand on a brick but slowly with some force. So if he is hitting slowly, the force, even though the effect of force is there, but the brick will not break. Now the same karate player in a normal way, if he hits his hand with same force but with high velocity, very quick, the brick will break. That means here there was the difference in velocity. So conclusion number 2 is effect of force depends on speed or velocity of the object. Now you just have to go through the conclusion line. Effect of force dependent on mass, effect of force dependent on speed or velocity. So what shall we do? We will combine both the conclusion and let us make a single statement. That effect of force, over here you can see effect of force is dependent on mass and speed or velocity of the object in motion. Right? The physical quantity which relates these two quantities is called momentum. Which two quantities? Mass and velocity. So what is momentum actually? The definition is the product of mass of any object and its velocity is called momentum of the object. So momentum equals to mass into velocity. Now this physical quantity which is totally new to us is represented by the symbol small p. So in formula we can write p equals to m into v. The SI unit, the standard unit of mass is kilogram and velocity is meter per second. So what will be our final SI unit of momentum? It will be kilogram meter per second. Note that it is dependent on velocity, so it is a vector quantity. And why we are studying momentum? Because ultimately it shows us that effect of force is dependent on mass and velocity. Thus, it has a relation with second law of motion given by Newton. Let us see that second law of motion in later part. First of all, let us try various sums or numerical which is based on momentum. Now, car of mass 1000 kilogram is moving with a velocity of 72 kilometer per hour. Find its momentum. So for finding momentum, we need only two things, that is mass and velocity. Now let us see the solution. Now let's see what is the given list. Given we have mass as 1000 kilogram, velocity as 72 kilometer per hour. Let us check the unit. Kilogram is alright, but we have to convert this kilometer per hour into meter per second. So what shall we do? Let us multiply 72 with our shortcut, that is 72 into 5 by 18. Now is 18 and 72 cancelable? Yes, 18 4s are 72. So ultimately our answer is 4 5s are 20 meter per second. Now you see we have velocity 20 meter per second and mass 1000 kilogram. So the only thing left is to put the formula. P equals to mv, that is equal to 1000 into 20 meter per second, and 1000 into 20 gives 20,000. Unit will be kilogram meter per second. So likewise we will calculate the numericals which are related to momentum. So momentum of car of mass 1000 kilogram moving with velocity 20 meter per second is 20,000 kilogram meter per second. So this is how we will solve. Next question let us see, that is another numerical in which it is said mass of a goods truck is 4,000 kilogram and mass of the goods which are loaded is 20,000 kilogram. Now if the truck is moving with a velocity of 2 meter per second, find its momentum. So given is mass of goods, that is 20,000 kilogram. So let us write 20,000 kilogram. Mass of truck was 4,000 kilograms. Now velocity of the truck is also given, that is 2 meter per second, and we have to find out the momentum. Now one thing that we have to take care is what is momentum, mass into velocity, but in this question what is the mass? It is the total mass of truck as well as the goods. So when we take mass it will be the total mass. So let us find out the total mass first of all. So total mass will be equal to the sum of mass of the truck. So I am writing m truck plus mass of the goods. So m goods, and that is 4,000 plus 20,000, that will give us 24,000 kilogram, which is nothing but the total mass. So I am writing capital M. Now we have got capital M, we have got V, so let us put P equals to capital M into V, and that is 24,000 kilogram into 2 meter per second. That will give us 48,000 kilogram meter per second. Take care of the units as well. So this is how we will solve numericals which are based on momentum. Momentum equals to mass into velocity of the object. So now I hope we are clear with the concept of momentum, how it is related to force and how it is related ultimately to mass and velocity. But again, what is momentum related with? So momentum is related with force. Now how it is related will be cleared by Newton's second law of motion. So now with many illustrations and activities, it is concluded that force is related to change in the momentum, right? To bring down a change in momentum, we need force, and for that we need some time as well. So this relation of force, change in momentum and time is nothing but Newton's second law of motion. So let us see what is the statement. The second law of motion states that the rate of change of momentum of any object is directly proportional to the applied unbalanced force in the direction of force. So that is why I have highlighted the important word. You see, the rate of change in momentum is directly proportional to the force. Clear? And if we are using the word rate, that means change in momentum upon time, and that is directly related to force. Okay? So you can say that Newton's second law of motion gives us the way to find out the value of force by a small relation formula which we are going to derive in the next slide. So that formula will be very important question for 2 or 3 marks in the exam, that derive Newton's second law of motion, F equals to ma. Right. So now let us see the derivation. The title of the derivation will be Derive formula of force F equals to ma, where F is force, m is mass, a is acceleration, and that will be on the basis of second law of motion. Now let us see how it is derived. So an object of mass m moving with initial velocity u accelerates at a for time t so that final velocity changes to v. Then let us start the derivation by finding initial momentum. I have written pi, final momentum I have written pf. So how to find pi? M into initial velocity, that is m into u, and final momentum m into final velocity, so m into v. Now we will find how much is the change in momentum, because Newton's second law of motion is based on change in momentum. So let me write it as delta p, and that is final momentum minus initial, so pf minus pi. What is pf? mv minus what is pi? mu. Anything common? Yes, m is common, so take m outside, v minus u will be inside the bracket. Now why we have found change in momentum delta p? Because it is related to Newton's second law of motion, which says, so we will write by second law of motion, the force, the unbalanced external force is directly proportional to the change in the momentum per unit time. So force is directly proportional to delta p by t. Now let us denote force as capital F. Proportionality symbol will be there, and delta p will be written as m into v minus u in the bracket upon t. Now remember from chapter 8 that v minus u, change in velocity upon t per unit time, is nothing but acceleration. So we will replace it with a. So our final formula becomes F is proportional to m into a. But removing the proportionality symbol will have to keep equals to sign along with a constant. So we'll write F equals to k into ma. But experimentally it is proved that the value of constant comes near to the 1. So negligible, so we will neglect it. So ultimately our final formula for force will be F equals to m into a. So what is that? Force equals to mass into acceleration. So this is the latest and the newest formula of force that we have got. So if someone asks you to find a force, what you will find? M into A, and that is on the basis of second law of motion. So in this video we have seen what is momentum and Newton's second law of motion and derivation of a most IMP question F equals to ma. Hope you like this video. Share and subscribe the channel. That's it for today. Thank you.